Hello friends, in this video tutorial let us understand the technique of naive for data mining in SSAS. Now for the purpose of this video tutorial let us go to SSDT, let us create a new project. Now we will store this project in data mining 3 and let us provide the same name to the project, that is data mining 3. Okay, so and we will select the first template, that is analysis services multidimensional and data mining project. So let's click OK. So blank project has been created. Let's add the data source. So it's connecting to SSAS data mining, so that's what we want. So let's click next. Let's use service account. Finish. Let's add data source view. Next. Now let us select target mail, we target email view. Next, let's call it as DSV as it is a data source view. Finish. Let's go to mining structures and add a new mining structure. We'll use existing table. Okay, so let's go to naive base method. Next, so we will be using vtarget mail data. Next, this will be acting as a case data, that is it will provide the data input. Now over here it has auto selected customer key as the key, which is the correct one, and we want to predict bike buying behavior, so that's why let's tick over here. Okay, now the input to this bike buying behavior will be, we want to provide discrete inputs, that is we want to provide input of columns which are of discrete type. Okay, because naive base biased algorithm works well with the discrete data input types. Okay, so let's select only the discrete columns in when we are working with this algorithm right now. So let's go to commute distance. Commute distance actually is a discrete value in our database. Let's go and see it. So we can see the commute distance is having discrete values, right? Also region is also discrete. Okay, right? So let's select commute distance, then email occupation and education will be discrete values, then gender is a discrete value, house owner flag is a discrete value, marital status is a discrete value, Indian name, number of cars owned, number of children at home, these are all discrete values. Region is a discrete value, total children is a discrete value. Okay, so these are the values that we have selected. Now we know that these values are discrete, so let's make them discrete. Okay, so let's click next. Let the percentage of testing data remain 30. Next, let's call this as mining structure. Let's call this as naive base. Finish. Okay, so now let's copy the name of our analysis services database. Let's go and provide the name over here, that is for the deployment. Apply. OK, and let's process our cube. Now in our database we can see right now there is no database with the name SSAS data mining 3, whereas if this is deployed then it will create the database with the name SSAS data mining 3. Okay, so let's go to process. Okay, so if we go to database now, then the third database has been created with our DS, DSV, right? We have not created any cube or dimension, right? For the data mining structure also, we can see that naive-Bayes data mining structure has been created. So now let's go back to our SSDT. Now in the data mining models, it has started showing the naive-Bayes data mining model that we have just created. So if you go to model viewer, then we can get the graphical view. Okay, so this graphical view suggests us that the number of cars owned is having maximum influence on the bike buying behavior when all these discrete columns or attributes are taken into consideration. Okay, so number of cars owned, it has the maximum influence on bike buying behavior, followed by total number of children, then commute distance, English education, number of children at home, region, and marital status. So marital status has the least influence on the bike buying behavior if we are considering these discrete attributes. Okay, also we can go over here, and this 1 indicates the data for the bike buyers and 0 indicates data for the people who have not bought the bike. Okay, and this is for total population. So we are interested in the column for 1, that is for the bike buyers. Okay, so if you see, then if commute distance is between 0 to 1 miles, then there is very high probability of buying a bike. Okay, similarly, if a person is having education of bachelor's or partial college, then the bike buying behavior or the probability of buying a bike is high. Marital status doesn't have much influence on the bike buying behavior. Okay, number of cars owned, if it is between 0, 1 or 2, then the probability of buying a bike is high. Also, if number of children are 0, the bike buying probability is high. So similarly, we can go through all the individual factors. Okay, now if we go to attribute characteristics, then we are interested in one value, that is for the bike buyers, right? And we can see that if the number of children are 0, then the bike buying probability is very high. Also, the marital status M and S, that is married and single, is not having much influence because both the factors are appearing together, right? But if region is North America, then the probability of buying a bike is high. Also, if the commute distance is between 0 to 1 miles, then the probability of buying a bike is high. Okay, and if we go over here, then we are interested in comparing the different attributes between two values, 0 and 1. That is, 1 is for the people who have bought the bike and 0 is for people who have not bought the bike. Okay, so if the number of cars owned are 0, then it favors the bike buying behavior a lot. Okay, whereas if number of cars owned are 2, then the probability of buying a bike decreases a lot. Okay, so there is almost very less probability of buying a bike, right? If education, English education is partial high school, then the person is not having that much probability of buying a bike. If the region code is specific, then the person is having very high probability of buying a bike. Also, if number of children are 1, then the probability of buying a bike is high. Okay, if commute distance is more than 10 miles, then definitely the probability of buying a bike is very low. Okay, so in this way we can individually study the impact of all the factors on our bike buying behavior, of which is shown by the value of 1 or 0. Okay, so using this distribution we can also understand the impact of individual factors on the overall predictable value. Okay, so I hope friends this video tutorial is useful to you. Thank you.